go. Okay, so we're going to start with finding the surface area of this pyramid. So once again, we have like two surface areas. The lateral surface area, which is all of this, or all of the sides, and then the total surface area, which is all the sides, including that bottom part, including the base. Because my pyramid has only one bottom to it, or doesn't have like a top to it, it's like a point at the top, we only have one single base. We want to double the base like we were doing with the prisms yesterday. To start off, let's just find that base. My base for this first pyramid is a square. So our area formula for a square, pretty simple, pretty easy. It's length times width, which are both the same number. So 16 times 16, or 16 squared, which just gives us, for us, let's see, it's over my paper, 256 feet squared. That is the area of just the bottom of my pyramid. Now, I need to find the surface area, or the lateral surface area of my pyramid, the area of all of those sides. Say I wanted to cover this entire thing in paint, just strip it on down and figure out how much paint I need. So I need to figure out what are all those sides of my pyramid. What shape are those sides? Triangles. So, if my shape is a triangle, what's our triangle area formula? Okay, so our area of a triangle is 1/2 base times height. Now for a pyramid, you might get confused because there might be two different heights you're thinking of. So if you look at the second pyramid, we have this three-dimensional height of my pyramid from the bottom of my pyramid going all the way straight up to the top of my pyramid. But that's not the height of this triangle that we're looking for. The height of this triangle is that length on the outside of my pyramid. If I thought I was like scaling up the side of my pyramid on the outside, that's my height. We call that height our slant height. The letter or the variable we usually use to represent slant height is an L. I don't really know why they chose L, but that's what mathematicians decided. So slant height is that height along the outside, or that length on the outside, from the top of your pyramid on the outside all the way to the bottom. And that's an important differentiation to make sure that this is different from your actual three-dimensional height. So if we're to use our 1/2 base times height to find the area of this triangle, the area of my side, the area of my side is 1/2 base of 16 times the height of 10, which if I multiply that all together gives me 80. So that's the area of just a single side of my pyramid. How many sides do I have in my pyramid though? I have 4 different sides, so I can take that one, or I have 4 of the same sides, I'm sorry, not 4 different sides. So I can take that, and I can multiply that by 4. So I can take 80 times 4, and that gives me 320. That represents all of my sides together, so that would be considered my lateral surface area. So if that's my lateral surface area, in order to find the total surface area, I just need to add my base to that, which we already found in our first step. So I'll take 256 plus 320, and that will give us 576 feet squared is our total surface area. Are we okay with that so far? Now, we took 4 steps to do that. I'm a mathematician. I'm pretty lazy. I want to reduce that. I don't want to have to take 4 steps. I want to reduce that down to, let's say, 3 steps. So rather than doing both of these in 2 separate steps, I'm going to squeeze that into 1 step. So we think, the only thing we really did with that second step was we multiplied by 4. We just multiplied by our number of sides. So really we took that first one, we took that 1/2 times our base times our height times the number of sides, which we'll say is S. And that's what gave us our lateral surface area. Well, if my base times the base times the number of sides is the length all the way around my pyramid. What do we call that number that's the length all the way around something? Perimeter. So rather than having base and height in here, I'm going to shrink this down to 1/2 perimeter times lateral surface area, which was the height of our triangle if we think about it. So your lateral surface area, or sorry, did I say lateral surface area for the L? That's our slant height. I'm sorry. I was saying the wrong word. So lateral surface area of a pyramid, any type of pyramid you encounter, is 1/2 times your perimeter times your slant height. So really, rather than doing 2 steps, I can just use this formula and do 1 step. And so that can change. I can find the area of my base, find the lateral surface area, combine them together, get my total. I'm done in 3 steps. And this works for any type of pyramid you encounter. It can work for square pyramids. It can work for regular polygon pyramids. It can work for circular pyramids or columns. So if we were to do this second one together, how would you find the area of the base? 6 times 6. It's just a square, length times width. So our area of the base is 6 times 6, which is just 36 meters squared. Simple, easy, nice. Now I want to find that lateral surface area. I want to use that formula up here. So lateral surface area, that's my 1/2 times my perimeter times my length. So 1/2. What would the perimeter of my pyramid be, or how would I find that? What was that? So the area of the base represents this whole area inside. I just want the outside length. 6 plus 6 plus 6 plus 6, or I can change that just to 6 times 4, which is 24. And then the last thing I have to multiply is my slant height. What's my slant height for this problem? Did they give us a slant height? No, they told us the distance from the outside to the center point. Then they told us the height from that center point to the top, but they didn't actually give us a slant height. How can we find this? So if I had like a cake of this pyramid, I took a knife, and I cut it in half, and I looked at it, just looked at the side of it. So I'm changing it from a 2-dimensional shape, I'm cutting it in half and turning it into a 2-dimensional shape. I'd get something like this, right? With a height of 4 and a length to that center point. So I just took my pyramid, cut it in half, I'm looking at it straight on. How do I solve for this?
Oh no. What's it called? Pythagorean.
Pythagorean theorem. A squared plus b squared equals c squared. But a squared plus b squared equals c squared, that looks like a cube. Do I know what this answer is without even having to do it? One of our Pythagorean triples. 3, 4, 5. So, if you don't remember that, if you don't remember this Pythagorean triple, plug in 3 squared, plug in 4 squared, solve for it normally. But if you do remember it, that's one step I don't have to write down, and that's one step I can just quickly move on from. So I know it's Pythagorean triple 3, 4, 5. So we can easily solve for those slant heights if we don't have it by using Pythagorean theorem. As long as we know the distance to the center, as long as we know that height of our pyramid, we can find that this slant height right here that they didn't actually show us is 5. And now we can go back to our lateral surface area. 5 meters, yes. Thank you, Amanda. And now we can go back to our lateral surface area. We know it's 1/2 perimeter, which was 24, times our slant height, which is 5. And then we can multiply all of that together to get 60 meters squared. And that is all of the sides of my pyramid, is 60. Last step. Total surface area is just both those added together. So 36 plus 60 equals 96 meters squared. Once again, this lateral surface area formula works for any type of pyramid. So really the only thing that's changing is how do you find that base? As soon as you find your base, use your lateral surface area formula, add them together, you have your total surface area. So the only thing that's really changing is sometimes it might be a little bit different on how to find the perimeter. We might have to work a little bit to find the base. But as soon as we find those, we're good. We okay with this? Same thing. The only thing that's changing though is instead of having a square bottom pyramid, I now have a regular polygon. So I have a regular hexagon, regular pentagon. We could have a regular octagon, or a decagon, or a square is technically a regular polygon. I always sort of think of these like little circus tents. If you think about it, the circus tent, they have like the little flat sides. They're not always like straight circular. That's what we have going on. So we want to find that sort of canvas of our circus tent. Luckily, yesterday we learned how to find the area of these regular polygons. We did that with our regular prism yesterday, that pentagonal prism. We sort of cut the pentagon into those little triangles, found how much each of the triangles were, multiplied it by however many pieces we had, and that gave us our total surface area. So we can use that, or sorry, that gave us our total area for the base. And then we can use that to find the area of this base as well, or the area of that base. Same idea. Once again, that little line from the center to the outside, that's our opossum, not opossum. And so we'll be using that again today. So what we did yesterday to find the area of the base, we know we were sort of dissecting it into little tiny triangles. So we're thinking, okay, if I like connect to this and connect to this, I can make a little triangle, and then if I created more of those, I would have a total of 6 triangles throughout my hexagon. So the area of a triangle is 1/2 times the base of that triangle. If each of these side lengths are 10, that's going to be 10, times the opossum of my triangle, or the height of my triangle, which is that opossum, which is 8.66. And then that gave us the height of one triangle, but if I want to find all 6 of them, I can just multiply that by 6, and that will give me each triangle all together. So this is our area of a regular pentagon, or regular any type of shape. 1/2 your base times your opossum times however many different sides you have. Multiply all that together, we should get 259.8 feet squared. That is our area of our base. We then want to try to find our lateral surface area, and once again we can use that same method we just did. 1/2 times the perimeter times our slant height. 1/2. Now my perimeter, if each of these side lengths are 10, and I have 6 of them in total, I can just do 10 times 6, 60. That gives me my perimeter. And then times my lateral surface area, no, sorry, times my slant height, I always said it wrong. Slant height we're told is 14. And so our total, multiply all that together, we get 420 feet squared. Last step, we know our total surface area is just those two added together. So we're 259.8 from part 1, 420 from part 2. Add those both together, we get 659.8 feet squared. And that is our total surface area. So even though our area of our base might have changed, we had to use a little bit different of a method to find that. We can still use those same 3 steps. Area of base, lateral surface area using that formula, add them together to get your total. I want you to try to find area, or the surface area, the lateral surface area of this second pyramid you have. So see if you can mimic those steps, see if you can copy them along. Yes. Okay. All right. For this problem, we started off with our area of our base. Once again, you're cutting up into those little triangles. So that's 1/2 times your side length of 8 times your height of your little triangle, which is your possum, your 5.51, times how many sides you have all the way around, which is 5. And so that should have given us a total of 110.2 centimeters squared. We then move on to our lateral surface area. So our lateral surface area, once again, is 1/2 times your perimeter times your slant height. So 1/2 times our perimeter, well, our side length is 8, and we have 5 different sides. Our perimeter, if we multiply those together, will be 40. And then times our slant height, which we're told is 10, which we multiply all that together, that gave us 200 centimeters squared. Part 1. And then for total surface area, once again, we can just add those two together. 110.2 plus 200 is just 310.2 centimeters squared. Any questions over that, or any of the steps we took? All right. So now we're going to move on to our final pyramid. Okay. We're going to move on to our final pyramid, our circular pyramids or cones, as Alex so questionably wondered about. All right. So we have cones here. Something to note about this first one, this 12 centimeters is supposed to be this line, not your height. I know it's kind of deceiving, but it's supposed to be like your slant height of your cone. But we can still use those same 5 steps we did on the last problem, on the last 2 pyramids we dealt with. The only thing is we have to think, okay, how do I find the area of my base? And how do I find that perimeter? So what shape is the area of my base for a cone? Circle. How do I find the area of a circle? So the area of a circle is pi r squared. So my radius is 9. I can just plug that in for my area of my base. Pi times 9 squared. That's a p, not a 9. There we go. Put that in our calculators, multiply that together, we get 254.47 centimeters squared. And that is our area of our base. Now we can move on to our lateral surface area, which we know is 1/2 times our perimeter times our slant height. How do I find the perimeter of my cone? Our circumference. So the circumference is all the way around the circle, which is the same as a perimeter is all the way around the shape. And so circumference of a circle is 2 pi r. So if I were to do this, this is 1/2 times 1/2 times 2 pi times my radius, which is 9. Then times my slant height, which is 12. Goodness. Okay. All right. 1/2 times 2, what's that? 1. So that's going to cancel out. So it doesn't even matter that I have 1/2 and 2 in there. It's really just pi times radius times slant height. So for your lateral surface area for a cone, you can just shorten it down to pi times your radius times your slant height. And that can be a little trick. And if you were to still remember, it's 1/2 times 2 pi r times your slant height. you'll still get the same answer. Which, if we add or multiply all that together, we should get 339.29 centimeters squared. Get frustrated. And then just like before, because we only have a single base and just that bottom of my pyramid, in order to find the total, I just add them two together. So 254.47 plus 339.29 gives us 593.76 centimeters squared. And that is our total. We okay with this? 23. All right. See if you can do those exact same things or those same steps. See if you can try to find this one. Actually, sorry. Before we talk about that one, what do you notice about that cone that's different? They give you a diameter. How would we find the radius? Just half of it. So half of 11.5 is 5.5. So use that for your radius. Find your area of your base. Find your lateral surface area, and add them together to get your total. Okay, so my area of my base, again, pi r squared, that should give us 95.03 feet squared. My lateral surface area, that's 1/2 perimeter or circumference in this case times the lateral slant height, which gives us 124.41 feet squared. And then our final answer of our total surface area, we just add those two together, and we get 219.4 something feet squared. 4. Are we okay with this? All right, last thing, we have a sphere. Spheres are pretty nice, pretty easy, because it's all a side. It just has one outside. It doesn't have multiple sides. It's just one fluid outside. And so rather than having a lateral surface area or a total surface area, it doesn't have a base, so it's all a single surface area. And so we have a single formula for our surface area of a sphere, which is 4 pi r squared. I can't really give you an explanation, I can give you an explanation, but I can't really give you a good explanation on where we come up with that formula because we have to use calculus to actually solve for it or to come up with that formula. But that formula works for the surface area of any type of sphere you have. The only thing you need is your radius. So if you were to look at this first one, all we have to do is 4 times pi times 6 squared, and that gives us 452.39 centimeters squared. So, yeah. So spheres are really simple, really easy. It's just 4r squared. And that is your surface area. We don't have to worry about a total or a lateral because it's all one thing. What's different about that second one? Diameter. So what's our radius? 10. We just take 20, cut it in half, 10. And so this one will be 4 pi times 10 squared. Simple, nice. Multiply all that together, you should get like 1,256 point something, 56.64 inches. That's how much you would need to cover the whole thing. Questions on any of these pyramids or spheres we talked about today? Right. Tomorrow we'll continue to practice surface area, some practice problems, and then on, let's see what, on Friday we'll review our formulas that we talked about and we'll take our assessment. Once again, you can use that reference sheet on your assessment. If you want to like jot some couple notes on that, you can. Obviously you won't have it on your actual state test, but you'll have it on these assessments. You'll also be able to use that same one on next week's assessment involving volume, but a lot of your volume formulas are already on your paper as well. Any other questions, concerns, comments, speech, rants? Right. And we will